Right. So let's Liam in this presentation. Right, and this is focused on the web frameworks. So web frameworks are really everywhere. If you have any kind of web application, you most likely have a framework. Spring, Struts, Smarty, there's plenty of them. And they really put the static code analysis tools to the limit. If it can handle your framework or not, that's really a huge difference. Right. So how do we deal with this in SCA tools? Right. So compile time, as I said, it's white box. We have no idea what happens in the runtime. We have to guess that. And the execution environment isn't there because the code isn't deployed. And also you might not put all the code into it, and the whole model is really fuzzy when you do that kind of analysis. And then we have the frameworks, choose your poison. And they want to help you out by doing, you have a URL and it sends you somewhere else. You have a lot of specifications in XML. They separate logic and views, MVC, magic in the background. So here we go, struts. Here's struts. Here's your JSP. Anyone still doing JSP? We do at my company. Yeah, there you go. Right. So you have a request in the JSP which goes into the struts config, which is a XML. And then it tells you to, then it calls this action, and then you're done, and boom, there you go, it sends you off to this page. So for a static code analysis tool, this is just a weird cloud. It's impossible to trace this one to this one to this one. Not impossible, but it's hard. So because we don't know at runtime what happens, we have no idea how the flow tracing is going to go. And no idea about the moving on here. So if we fail to do the flow tracing, the tool is going to miss a lot of stuff. False negatives. So baby is going to show up anyway. And if the flow trace is, if the tool tries to say, it's broken here, but I think this happens, you will have lots of false positives on your hands. So here, if someone inputs something else here, we have no idea what's going to happen. And there's cross-context propagation. So when the SCA tool is trying to build up this tree that I showed you, it has no idea what's happening here, so the flow trace just gets messed up. And then in the results, so this would be a source, this would be the path. But is this a problem or not? Because we don't know what happens here. This happens at execution time. So we assume that it's all good, and then we are mistaken in some cases. Or if we assume that it's always dirty, then we're also lying. So when you have the URLs that get invoked by the framework, or actions that calls on different views, this is all listed in the XML. So the XML is really the key. If you can figure out how that works, then you can actually break open these frameworks and get good results. Right? So we have struts. Anyone familiar with struts? Oh, a couple. Okay. Spring, I think, is quite similar. Am I wrong? I don't see a big difference. Sorry?
Just does it better.
It does it better, right? So it struts 2.0.
No, the structure has a 2.0 version.
Oh, okay. Okay, so 3.0? Right, so as the source code analysis tool has to somehow figure this out. How is this XML connected? And then, are we supposed to support all the frameworks, the old ones, the new ones, the most commonly used ones? I'm not going to make you talk to each other here, because of course this is a trick-ass question. Because some people make their own, yes?
Just a question, do you have to support the framework? Is it not possible at all to just, I don't know, try to catch them all?
Yeah, exactly, which is what happens if you do that. We end up here. So if you assume that, yeah, okay, this all flows out to everything and it's always tainted, then you will have lots of false positives. And then no one wants to use the tool because they say, yeah, you find a lot of stuff, but it's all bullshit. So you're wasting my time. Right, and there's of course the homegrown frameworks, which, you know, only you, the developer, have the specification. Only you know how it works. So applying the SCA tool to your code base with your homegrown framework is going to find absolutely nothing in most cases, which is a lie, of course, because that's false negatives. So you can solve this.
Is that also the case? I mean, if you go on the source code for your homegrown framework, or just if you use the compile part?
Sorry.
Is that also true if you do an analysis of the source code on the framework, you know, on homegrown framework?
Yeah.
Or is it only the case if you have compiled sort of your framework?
Right. So the question is, does this apply if you just analyze the framework code or the runtime code, the compile code? I would say that doing the analysis on the uncompiled framework code could find some stuff, but most likely not, because it's not until you actually put in your business logic and all that stuff into it that you figure out where stuff comes from and how it's propagating.
Yeah, I was more thinking of running everything together, your own framework and the code.
Right.
So you do the trial on everything together as a code base. Would you find the problems then, or?
Yeah. So if you run it all together, since this is source code analysis, you have no idea what's, like we said with the. I'll go back here. This is excellent questions. Thank you. We have the. Where is it now? Here we go. So when structs is handling this in its XML, so let's say that your homegrown framework has the same kind of thing. It's based on XML. And then it figures out that what should happen is that this action should be invoked, which then goes back into the, where it says that, okay, if this was successful, then send them to the JSP. And figuring this out for the SCA tool is extremely hard, because this isn't really code. This is just listings of, if this happens, then go here, and like Spring has this kind of XML hell configurations as well. So the tools will have a hard time figuring out. Yes, sorry.
Yeah, a related question when you're talking about the config path and stuff like that. I've seen in some frameworks, at least on the PHP side, that there are some kind of input validation framework thing. We can say like if like the action is edit article, ID must be an integer, and then that would kind of untaint some data. You know if the current tools are good support for the type of input validation aspect.
Right. Yeah. Depending on the tool, if it can the tools handle input validation that is existing in, say, the JDK or something like this. Some of them are really good at it. Some of them are not. If they're able to figure out that, oh, passing through this function means sanitizing against this or this, validating input, then yeah, so some can handle that, some cannot. Right, going back here, yes, sorry?
I think what you're saying, coming back to the question,
Yeah.
the crucial thing is if you're modeling your program with reflection and having your program logic being executed and at a higher level being modeled by your variables and data. That's the problem for the SEA to follow when it's not static code any longer. So it doesn't matter if you have the program code for the Spring framework or anything like that. The problem is that they represent the program on a data level and not on a code level.
Yes, exactly. Thank you. So the thing here is that it's not source code anymore. So it will have, depending on what the input is, it will invoke different things. So if you use this reflection, then the source code analysis tool it could just guess like everything goes everywhere, but then it's not going to get any good results. So it needs to have some way of figuring out, like simulating how this works. Are you guys still following me? Is this still okay? So, right. So reflection. Program modifies its behavior and how it works, how it's built up, how it runs at runtime, which is not known in white box time, which is pre-compiled, pre-deployed. So, we did this. Where were we? So you can do assumptions, but if you assume, you're gonna get bad results. False negatives or positives. We went through this, right? XML, cross context.
If you have another example in Java nowadays, you could, for example, have JavaScript in Spring in Java, and you could run it through the Nashorn JavaScript engine, and your SCA tool wouldn't catch that if it's Java-based.
Yeah.
So you could have heaps of code in a Spring, which is being executed, and the SCA tool has no idea.
Right. That's an excellent suggestion for an example.
It doesn't have to be XML. It's some program represented in a string.
Yeah. Right. So how do we attack this problem? You could have it if you hard code the configuration, like before every scan, you can hard code the tool to understand how things work. It's gonna possibly 1 or 2 times, then you're gonna be fed up with that and not do it anymore ever. And you could have the tool do it for you. So the tool is hard coded in how it handles different frameworks, which works fine if you have the exact framework that the tool supports. Best thing is, of course, if you could have this happen dynamically. So then you could input whatever your framework is and have that handled by the tool. So this is what CodeSecure did, how CodeSecure handled Spring and struts. And I don't know, but I'm guessing the checkmarks is doing the exact same thing. So you have your framework configuration, which you input into the flow. And then you have some kind of code generation that simulates all these paths that the code could take. So this is a struts example. You have a registration form in XML. And then your tool goes into this reflection part here. Oh, okay, if this happens, then this class is going to be called. And then it could just make that up in its own Java code. So like transient temporary Java code that is generated for your scan runtime. So on the fly. Boop. And now, voila, you have your flow tracing capabilities. So you know that this happens, and then you could go either here or here. So this is where the sales talk come in, I guess, because this is what CodeSecure did. It works really well. It has no impact on the implementation or the code itself. And you could have it, like the glue code injector could be separated, so you could buy it from someone else. You could have it inside a tool to start with. And you can extend it. You can, of course, apply it to your own framework, which is what a tool should be able to handle, the big frameworks and your own. And if it doesn't, it's going to be pretty pointless in using them. And it extends the coverage. So, here the glue code injector comes in, and it puts in this code. We have this source code is there from the beginning. And then some more glue code. And then you have the sync. So by doing this, you will know that this is a possible source. This is where you get something from the request. And then you can see where it goes on in this one and this one. And then you can look into those code those files and see if this one, if there's any syncs, and if the tainted data gets used anywhere. So I would say that checkmarks, Coverity, CodeSecure, they HP Fortify as well. They do something like this because they're pretty good at handling the frameworks. But if your tool doesn't, then it's no good. If you have your web application, which definitely uses some kind of framework, your own or someone else's, it has to have some way of handling this. And
Sorry.
yes.
When you say that if your tainted data gets used anywhere, you
Yep.
mean if it gets used anywhere without having been sanitized?
Yes, exactly. Yes.
Yeah.
So your possibly tainted data
Yeah.
gets used anywhere. So here's
Yeah.
this happens. I can forward, and then this could be tainted. If you input first name, not Lars, but something nasty, and then it gets outputted here, this could be a cross-site scripting happening. Right? Yeah. So it's I mean the tools it doesn't know if the data is tainted or not because it's not runtime. It just says that if it is tainted and I don't find any validation happening on the way or sanitization, then you could end up in trouble because the sync is there using that data. So the web frameworks really make these tools, they make or break them. If they can handle this well, then they're really good, but some of them can't. And if they can't, they're not going to find any stuff in your code. And if they do, they're lying. Some tools can scan them effectively on the fly translation. And possible to listen close to me. Right. So if you have some kind of like the glue code injector, that one could possibly be applied to different tools. So if you find a good one that works well, like a plugin that works well with Coverity and checkmarks and HP Fortify or whatever, then that could really make your tool fly. So if it doesn't work so well, and then you have something that like a framework handling plugin, then that could really make a big difference in the results. And that's it.
Another question.
Yes.
So these tools that dynamically translate this static code, this data,
Yeah.
into code, are good, I guess, in an organization that you have either a lot of different frameworks or a very diverse environment. What if you have, let's say, one framework that consistently is used throughout your organization, and then you have an SCA tool that does the dynamic translation and another one that just supports that specific framework? Which one would you choose? Which one do you think is better? I assume also the dynamically translated is much more expensive, but let's keep cost out of it for the moment.
Alright, so you're asking if you have one tool that has hard-coded support for the framework, and another one that has like some dynamic glue code injection, definitely go for the hard-coded one. Because then if they're doing just that one framework, I would assume they do it really well. And then have like the dynamic glue code injecting like a plugin or a tool that has that plugin bundled into it. They should be able to work fine, but if you don't, I mean, if you have just the one framework and you're never ever going to change, you're not going to add any frameworks, add any new projects, then just get the one that works really well for your framework. So this is as deeply technical as I'm going to get. Yes?
Question. So there is not a single free, potentially open source flow analysis, flow tracing tool?
Not that I know of, no. But if you write one, you can...
You will sell it.
I can help you out. I've worked on the core analysis.
Yes.
But yes.
There is actually some work that is being done on that aspect in the LLVM compiler, mostly research. But there is some work on that, on static code analysis that is being done on the LLVM compiler.
Okay.
But it's mostly academic research by now. So.
Okay. So there's an academic research done on, what was the compiler? IBM?
LLVM.
LLVM?
The LLVM project, which is, for example, the static code analysis tool part in Xcode, the Apple development tool is the LLVM static code analysis tool.
Okay.
If you do static code analysis on the XC, and Swift and C++, that's what you're going to be using.
Right.
And the big limitation with the LVM is that it can only scan one compilation unit. And they have the goal for some future release, it should be able to do a global scan on an entire C build. But for now it can just scan a single file.
No.
Oh, excellent. So there seems to be some work done here. But the like I was saying, there's pattern matching and there's flow tracing, and then pattern matching is for free. Flow tracing costs a lot of money because it's really hard to do it well. And if you do it well and you don't have frameworks, then you're not gonna make any money at all. Yes, question?
So you spoke a bit about web frameworks.
Yep.
But like a large part of the Spring thing is the dependency injection, the versional control thing.
Yeah.
Did you handle that?
Yes. CodeSecure that I worked on handled that dependency, like the auto wiring features.
Yeah.
Yeah. It handled that as well.
In the same step.
Yes. Yes. So like glue code injection thing. It's funny because yes, Robin.
How do these flow analysis? How do they handle if you have a large cyclical? I mean, if they do this glue code creation and things, it seems to me that they could get stuck in a loop. Do they just give up after a certain depth is reached?
Excellent question. It's almost like I planted that before we came here, but it's not, because we had this exact problem. So assume here that we're in glue code injection mode. Frameworks, magic background. Yeah, this is gonna take a while. Oh, here we go. Boom, boom, boom. Right, so what we're saying is, I think, what if this is a type that is like registration action extends action, or like you don't know the specific type. You don't know it's like T of type something, and then it's being called again and again and again. Yes. If you don't handle that well, then you will run out of memory eventually. what we did on CodeSecure is that we set a limit of 2 or 3, I think. So after 3 calls to the same like type this, and then it was when it came back to 3 times, that's when we just cut off the tracing and moved on. So I mean, there are lots of ways in source code, especially PHP, I say, where you can get stuck in these infinite loops because you don't know where you're going, or the code doesn't tell you really where it's going. It's just bouncing you around back and forth to the same place, and you have to handle that. We handle it by giving it like a maximum depth, like you said. We also did not handle it in some cases because we just ran out of memory and the scan never finished. Like the BB forum, PHP BB. Anyone familiar with that? Yeah, that was like our worst enemy because sometimes we just end up in these huge loops. I should have planted that question to you earlier today, but because it's a really good question. But I didn't, honest to God. What comes up next is I'm gonna show you some of these tools and how they perform on WebGoat. But before that, we're gonna have another break. 10 minutes, I think, this time. Yeah.